Hello, it's me, and look what I got here. I got myself a Triamese Cube. Now, I've actually done a Siamese Cube before, which is just two. This is a Triamese one. Now, I'm to understand that there's different versions of it. Some of them have the cube that's bandaged up to here. This one has it down here. This is the mass-produced one. I think people have made homemade versions of that, but basically what this is it's three cubes where the end corner layer here are combined with another cube over here. Now, you'd think with a situation like this that you can just solve it like three individual cubes, but it's actually nothing like that. It takes certain strategies, as you've seen with the Siamese cube. When you're doing each individual cube, the end cubes over here, the problem is, unlike Rubik's Cube here, you only have certain moves available to you. So in many ways, this is like a bandaged cube. And the bandaging in this case means that all I have available to me is an R move, an M move, a U move, and this move over here, which I think is an E move. E refers to this slice here between the top and the bottom, or equatorial. M, or middle, stands for this move, which is between the right and the left. Where you go with the M follows the pattern of what the L is. So this is M, and this is M prime. Just like those same movements would be L and L prime. So because of that, I can only solve this using those particular moves, which means the strategies have to change. But it gets worse. The hardest part is this middle one, because now I'm bandaged even more. Because what moves are available to me? Well, if I turn this down, I don't have R moves or L moves. I sort of do, but in a very restricted way. Mostly, I just have up moves and middle moves. So how do I solve this thing? How do I navigate my way through it? Well, what I should do before getting into this is introduce a couple of concepts. One of which is if I want to make a move over here and use the same algorithms. And I'll tell you that the way I'm going to go through this, at least with these portions of it, is going to be a little different than I did with a Siamese cube. And in some ways it's going to be easier in some ways because it's not going to have any new algorithms, just surrogate moves. For instance, if I wanted to do an F move, I can't move that here. I can't do an F move here because I'm bandaged. But I can do a surrogate F move by moving this here, then do an F move over here, and then bring it down. So that basically acts as a surrogate F move. That's pretty simple there. Now, in order to figure out how to solve this, basically I need to design a couple of algorithms, or make use of a couple of algorithms that moves middles around. Now, you'll notice in the tutorials that I've done, I've particularly stayed away from jargon. In other words, you haven't heard me say things like OLL or PLL or F2L in none of my tutorials, and there's actually a reason for that. Using those terminologies is a very good way for people who do a lot of cubing or do speed cubing to communicate with each other in a quick way, rather than just describing everything. My intention with the tutorials is to target it at pretty much anyone. Anyone picks up a puzzle, and to see if I can describe what I'm doing as opposed to give a vocabulary word to it. It could be okay using it as a shortcut, but I figure rather than just say F2L or OLL or PLL, I'll just describe it instead of using jargon, because I'm afraid that I might exclude certain people and have them have to look up what I'm saying rather than focus on what I'm doing. But in this particular case, I'm gonna use some of that because it does kind of help describe the situation. For instance, if I were to say F2L, what that really refers to, F2L means first two layers. So when I'm doing a layer by layer solve, I'm doing the first two layers. It's the beginner's method. Now there's other types of F2Ls, other types of strategies. You've only seen me use one, and that's going to be this layer, and then doing algorithms to put these middles into place, and that's the first two layers. The last layer can be thought of as two aspects. We talk about orienting different pieces, components. Orienting means basically flipping things in the right direction. So if you remember in the last layer, there's a way of flipping the edges. Well, that's called orientation. It's a process of flipping things so that the colors are on the right side. So when they talk about OLL, that's orientation of the last layer. And there's a variety of OLLs that are out there that can help you out. The one that I do in terms of the edges is the FRURIUI-FI. That'll help orient these correctly. There's also orientation of the corner, which I do as a separate step, and that's my RIDIRD until they're all oriented. When you talk about taking one piece and shifting it to another slot, in a predictable way, we say that that's permuting or a permutation. So an orientation is flipping, a permutation is translating it from one place to another. So that process is called a PLL, or permutation of the last layer. Various techniques are called perms, which we'll get into. So there is one PLL that I use, permutation of the last layer. For edges, that's the R, U, RI, U, R, 2U, RI. So that basically shifted these guys. It kept these the same, but it shifted these guys. So that's what's meant by that. So why did I go through that when I've never done that before? Well, I'm going to need that because to solve this middle layer, I have to do a variety of different strategies than I've used before, different algorithms. I can't use the PLL that I've used before. I cannot use the permutations because it means doing a whole bunch of moves that aren't available to me. So there's other types of permutations that only take middle moves and U moves. And as long as we know those strategies, then what we can do is we can apply them in the proper way. So let me go over a couple of what those are. The first kind you see me do of switching these things is what I would call an adjacent, there's adjacent edge swaps and opposite edge swaps. I haven't called them PLLs, I've just called them edge swaps because that describes what it is rather than putting jargon to it. But there's different types of permutation algorithms that can cause these to move around in different ways. One of which is called an Hperm. So an Hperm basically flips these two and flips these two. Just for the sake of demonstration, flipping these and flipping these at the same time, the algorithm for that would be M2, 1, 2, U, M2, U2, M2, U, M2. So as simple as that, you can see I've got all of these dots over here and that flip these two and these two. Now, although that was pretty simple, it is a new algorithm. So I prefer just to do two sets of opposite edge swaps, 2R, 2U, 2R, 2U, 2R, 2U, creating placement issues here. Then I have these two over here, so 2R, 2U, 2R, 2U, 2R, 2U. Yes, it took me longer, but I would much rather take more steps and memorize less. But that's an example of what an Hperm is. But there's a couple of other perms that we're going to have to know to solve this. Kind of some neat ones, actually. One is called a Zperm. Now, a Zperm will flip these two and these two. So if you can imagine it forming like a Z pattern, sort of. And what the Zperm is going to do, the algorithm for that, and it's fairly straightforward. It's all a collection of M's and U's. And I'm going to post these as well. But that's going to be M2, U, M2, U, M, U2, M2, U2, M. So because this is just a permutation and not an orientation, we didn't flip anything, but actually we'll bring this back here. But if you notice, I took this yellow one and put it here, and this green one and put it here. I took this blue one, put it here, and white one and put it here. So what we did is we flipped these two, and we flipped these two. So that was my Zperm. So once again, and I just think of it in terms of collections of M's and U's. So M2U, M2U. Then we just do M, U2, and M2, U2, and M, and U2. So that flips it back. The last one that we're going to have to know is what's called a Uperm. What a Uperm does is it's very much like what we did when I did the RU, RU, R2U, RI. Because notice what that is, that kept this here, but it rotated these around. What this one does is it does the same thing. It keeps this one here and rotates these in kind of a U pattern. So if you can imagine, this comes here, and this comes here. So it gives you a sort of a U pattern. But the neat thing about this algorithm is it does not change these guys. The thing about these PLLs is it does not affect the orientation of, say, corners, if we're going to do that. This one is kind of a neat one too, this Uperm. This will stay the same, and these will all turn. And that's going to be starting off again with an M2, U, then MI, U2, then M, U, then M2. So what did I do? Well, this stayed the same. This yellow one went here, this white one went here, and this green one went here. So we did a nice little U shape over here. Now these algorithms are not too hard to keep in mind. They have kind of a rhythm to it. So in this case, we're going to start off with an M2. M2, we do a U. We do an MI, 2U. Then we do an M. We do a U, and then we do an M2. So I basically danced around all the different types of M's, M2, M prime, and M, doing U's in between. As you can see, we can shuffle these guys around without affecting these guys over here, and that's actually going to be important. Now, there's two other algorithms that you're going to need to know. Sorry about that. And these are orientation algorithms. So what I did was PLLs. Those are orientations or perms. The next are going to be some orientation algorithms because you're going to come about situations where you have issues with orientations. So the orientation algorithms that we're going to have, there's going to be one which is basically going to do this. This is going to stay the same. Once again, this will stay the same. This is going to do also a U pattern, but it's going to have a fixed way that it's going to cause orientation changes. This will stay oriented and stay the same. This will come over here and slide over here and still be oriented correct. So this red one will be up. This will flip over here, so it's like an opposite U. This will flip over here, but it will flip. So this red one will be down. This will come over here and this will flip. So this red one will be down. So the overall effect is this will stay the same. This will switch over here and stay the same, oriented correct. This will flip over here and be oriented opposite, and this will flip over here. So these two will eventually be oriented opposite. And this one is fairly intuitive, actually. It's a nice and quick one. And that's going to be M-I-U-M. Then you do U2, and do it again. M-I-U-M. So as promised, this stayed the same. This white and red one shifted over here and stayed up. This yellow one turned over here, and this turned over here. So with that said, in order to get this back, if I wanted to say get this back, I can turn this over here and orient this correct. I know this will stay the same, this will shift over here, this will flip here, and this will flip here, and they'll all be oriented. So let's see if we can quickly do that. Again, pretty easy algorithm, and that's going to be M-I-U-M, U2, M-I-U-M. And that orients everything correctly. And then what you see is I have this situation, and if you wanted to practice our Hperm, we can fix that instead of doing opposite edge swaps. So that's going to be M2, U, M2, U2, M2, U, M2, and you got it. Okay, one more for good measure. And again, this one comes pretty easy as well. This one will keep these two the same, but will cause these two to be oriented incorrect. So that'll cause these guys to flip. With this one, think of M-U-M-U-M, U2, M-U-M-U-M, U2. But the first set of three M's in the MU's are going to be M primes. So M prime, U, M prime, U, M prime, U2. Then M, U, M, U, M, U2. So basically what that did is that keeps these here, but it flips these. Alright, so from time to time we may need that, but the good thing is it's all M and U moves. So M-I, U, M-I, U, M-I, U2, M, U, M, U, M, U2. Okay, those are a demonstration of the algorithms that you're going to need, but not so fast. We're going to have to discuss strategy with this. One further strategy to understand when dealing with the middle layer is I'm going to want to, from time to time, define what my U layer is. Sometimes it's going to be this, but sometimes I need to have access to move this one. So to make this my up layer, I'm going to move this to the side and this down. Now this becomes my up layer. And I can keep wandering around this puzzle doing the same thing. If this needs to be my up layer, I'll move this up here, which will free this to move down here. And I got myself another up layer. So that gives me a little bit more versatility. Before embarking on the scramble and then the solution to this, I will say one more thing. a lot of the aspects to this, I've introduced all the algorithms you're going to need to know. Everything else has to do with strategy. I could assign algorithms to almost everything that I do. I would not recommend doing that because in addition to the alterations of the algorithms that are known to us, we've got newer ones. I do know that sometimes people get a little bit put off if I keep using words like intuition or goes in just by planning or strategy. And sometimes people really just want to know what the algorithm is. Well, I'm not going to be able to really do that because honestly, when you're solving things that you can visualize, it's hard to kind of just say it at the same time. But what I will do for those people is I will describe what I'm doing by movement so that if you wanted to, skip back and just write quickly down exactly what I'm saying in order to make something happen, you can do that. So I'll try to accommodate all of that. But in the meantime, we're going to go ahead and scramble this guy and see how we can get this back in place. Triple abracadabra.